Welcome to qnawire.
Okay, so this is the motion for the pendulum. So it will swing back and forth, and it should be angle theta here. So the equilibrium position for the pendulum motion here should be the green dash here, okay? And which means that is when the angle theta here becomes 0, okay? So let's say theta equals 0. And the force of the pendulum should be the gravity here, which is mg, and the tension from the string. And same thing for here, tension. And if I decompose the gravity, there will be mg cosine theta going along the direction of the tension, which is like this. So mg cosine theta. And there should be mg sine theta here, like this. And same thing for this side. And this kind of motion is considered vibrational motion, okay? Because the restoring force is depending on the distance from the equilibrium position. So therefore, the pendulum motion is the vibrational motion. And then this is the motion of the beach ball. And the black line here is the surface of the water. Okay, so we bounce around the surface of water like this. So as you can tell, the equilibrium position should be the green dot here. So the equilibrium position should be when the center of gravity of the ball at the same level of the surface of water. Okay, so let me see the green dot here, equilibrium position. And the force that was acting on the ball should be the gravity of the ball, which is mg here. And the restoring force, which is something like this, Fr, and this point is mg again, and this point is restoring force. For this one, should have a restoring force like this. And the motion of the beach ball should be vibrational motion as well. It's because the restoring force is also depending on the distance from the equilibrium position. So this is a vibrational force. And then this is the graph of the motion for the medicine ball. So as you can tell, the equilibrium position should be when the medicine ball was on the ground, okay? Which is, let me use a different color. So it's the equilibrium position should be this one and this one. Equilibrium. And the force that the ball was experienced is gravity when it's in air. I mean, it's experienced gravity all the time. So gravity here, gravity here, gravity here, gravity here, and gravity here. And the second force should be the restoring force, which is the force that was point upward. And the motion by the medicine ball here should not be a vibration motion because the restoring force is constant, which is the gravity of the medicine ball. Okay. So the restoring force in this case is actually equal to mg. So therefore, it's not a vibrational force. So it doesn't depend on the distance from the equilibrium position. So not vibrational. And these are the answers for this question.